Hello everyone. In this lecture I shall discuss the Cauchy integral formula. In the previous lecture I have discussed the Cauchy integral theorem. Okay, you see this Cauchy integral states as follows: let fz be analytic within and on a simple closed path C and z0 be a point, right? So we have a simple closed path C. Suppose we have a simple closed path C. So this is a simple closed path C, right? And fz be analytic everywhere within C. fz be analytic everywhere within C. fz be analytic everywhere within and on C. Within and on C. Right? On C also. And z0 be a random point. z0 is something a random point here. z0 is a random point here. Right? z0 is a point anywhere within this. But it is not associated with fz. fz is something different. fz is something different. And z0 is a random point here. Right? Within C, but it is within C. This is my C now. Right? Then the value of f at the point z0. The value of f at the point z0 is given by 2 pi I into integral C fz divided by z minus z0 dz. Right? The integral is taken in counterclockwise sense. The integral is taken in counterclockwise sense. Okay? Taken in counterclockwise sense. The orientation is counterclockwise orientation. Sorry. So the orientation here is the counterclockwise orientation. So the integral is taken in counterclockwise sense. So or if I separate it out, this is equal to, right, this is equal to, bringing 2 pi I to this side, 2 pi I by this, right, this. So now in this similar lines, we may consider this C within a simply connected domain, or we may have suppose we may see it, we have a multiple simple connected domain D, and C is a closed path, and C is a closed path. C is a closed path here, and this is a fz is analytic everywhere. fz is analytic everywhere in D, in a simply connected domain D, right? And C is a closed path. C is a closed path here. Now this C includes the internal point as well as the boundary points also, right? And z0 is my any arbitrary point here. z0 is my any arbitrary point here, right? In that way, in a multiple connected domain, C is a closed path containing within D, right? In that way, or directly we take C is a closed path. And in the previous lecture I have told you how the multiply connected domain works there, right? So now if we evaluate a simple integral, evaluate integral C, this fz by z minus z0. Now this integral is of the form, integral C fz by z minus z0, dz. And what is my C here? C is z mod is equal to 2. So it is a circle with center at 0 and radius 2. It is a circle with center at 0 and here radius is 2 here, right? So now if you think this, now what is your z0 here? Your z0 here is, z0 is your 1, z0 is your 1, and what is your fz here? fz here is z square minus z plus 1, right? So then what is this integral says according to this integral? Now it is analytic everywhere, right? fz, you see, fz is this, it is analytic everywhere, exists everywhere, inside and on the boundary also, it is analytic everywhere. And here z0 is a point, z0 is a random point, 1 is here, so my 1 is here, so z0 is a point within this. So clearly we can write Coming to the solution. Here fz is analytic everywhere, and z0 is a point, right, within C. So therefore, by Cauchy integral formula, this integral C fz by z minus z0 dz is 2 pi I into f of z0. Right. So what is f of z0? Here f of z0 is here f of 1. Putting z is equal to 1. This will give you 1 square. 1 square minus 1 plus 1. So this is my 1 here. So this is equal to, this will give you, this is equal to 2 pi I into 1. Is here 2 pi I. Okay. So before we have our details of discussion, let me to introduce myself. Myself, Professor Susanta Kumar Paikray, currently working as a Professor of Mathematics at Veer Surendra University of Technology, Burla, Sambalpur, Odisha, India. So without much delay, let us discuss further examples and further details. Coming to one more example, you evaluate integral C e to the power z by z minus 1 into z minus 3. C is z mod is equal to 2. Now we have to think which one is z0 and which is my fz. So first you draw the path here. So the path here is a circle with center at 0 and radius 2 here. Now you think about the denominator here. Now my 3 is here. 3 is my here. Right? 3 is my here. So 3 is outside here. But where is my 1? 1 is my inside here. So this 1 can be taken as your z0. Right? So the remaining part I can take it fz. Because if I take fz is this, then it is analytic everywhere. So this integral I is equal to, I can write it. So this integral I is equal to, I can write it, integral C e to the power z slash z minus 3, right, and divided by z minus 1 dz. So it is my of the form integral C fz by z minus z0 dz. So what is your fz? With your fz is equal to, fz is e to the power z by z minus 3. E to the power z is analytic everywhere. And because of that z minus 3 in the denominator, it is not analytic at 3. But 3 is outside. So which is analytic everywhere? Which is analytic everywhere. Right? Analytic everywhere in C. But what about my z0? But z0 is equal to 1. So in C, it is analytic everywhere. And my z0 is a point here. 1 is a point here. Right? And z0 is equal to 1. Lies inside C. Lies inside here C. So what will happen? Now what is my f of z0? So my f of z0 is e to the power 1 by 1 minus 3. So this is minus of e by 2. So by Cauchy integral formula, so therefore by Cauchy integral formula, this integral I is equal to, right, 2 pi I into f of z0. So this is equal to 2 pi I into minus e by 2. So this is minus of pi e I. So this is your answer. Now the integral, no direction is given, means it is by default the integral is counterclockwise. If the clockwise will be given, right, if it is asked what is the answer in clockwise sense, if the orientation is clockwise, then simply just a negative sign. It is in counterclockwise sense, right? So this integral here is in counterclockwise sense, and the orientation is counterclockwise. And what will be the integral? Right, in clockwise sense, the answer integral will be simply the negative of this. This is pi ei. Right, this is pi ei. If it is asked that what is the integral in clockwise sense, then it is simply pi ei, negative of the answer in anticlockwise sense. Okay. Now let us extend this Cauchy integral formula CIF for multiply connected domain. Multiply connected domain will extend this formula. Let fz be analytic in a ring shaped region or annular region D, bounded by two closed curves C1 and C2. Right, means I mean to say here we have a two closed curve. This is a curve C1, and this is a curve, another curve is my C2. Right, the orientation is here. Now this, it is analytic within the annular region. So this is my annular region. Right, this is my annular region, and this region I call it, and this region I call it my D. D is my annular region. Right, this region is my D. Clear? Let fz be analytic in a ring shaped region D, bounded by two closed curves C1 and C2. Right, then for any random point Z0 in D, means Z0 is a random point here. This Z0, you say this Z0 is a random point here. This point is my Z0. Z0 is a random point here. Right, then for any random point Z0 in D, f of a is equal to 1 by 2 pi I integral over C1 minus 1 by 2 pi I integral over C2, this. And this is my Z0. Right, this is my Z0, f of Z0. And one more thing I want to mention here. This is my C1 is the outer circle. It is in anticlockwise sense. It moves in this way, and here it moves in clockwise around this circle. Right, again it move outside. So here, this is in that way the path is multiply connected. Means here the orientation is counterclockwise. Right, here the orientation is counterclockwise, and here the orientation is clockwise. Right, it is clockwise. It is anticlockwise. So this is your Cauchy integral formula for multiply connected region. Right, this region is not, you think that it is circular. If I take this is the region here. If I take this is a outer path C1, and this is a inner path C2. Right, C2, then also it's okay. Now we have the annular region. This annular region is here. Okay, so it is not always mean that it is a circular path. Now here this orientation is counterclockwise orientation. Okay, and here this orientation here is this, the center here in clockwise orientation. Again it leaves out. Okay, then in counterclockwise orientation, and it completes it. Right, so the region may be like this. Clear? So let us see one application. So now let us evaluate this integral. So we have to first understand the path here. The path is at center 2i, radius 2 is the outer path. Suppose this is my outer path. It is here 2i, say center. One more thing, center is 2i. So you have to change this path. Center is 2i. So you take the coordinate plane here. Right. Suppose this is my 2i here. This is my 2i here. the center is 2i, radius is 2, so it will touch this 2, right? It will touch this 2, it will come up to here 4i. So this is the outer circle, and what happens to your inner circle? It is z minus 2i mode. The center is 2i, but the radius is here half here, okay? The radius is here half here, right? So now what about the denominator? What is I here? I is something here. I is something here, right? So now you see fz is not analytic at -1. Here fz, if I take this is my -1, and I can break it now. So this is equal to, I can write it, this integral I, say this integral I is equal to integral c here ln z plus 1 divided by z plus I into z minus I. So what about the denominator? So your denominator is here z plus I into z minus I. So we have, looking the denominator in mind, your minus I is here, minus I is here, right? This is your minus I. Minus I is outside. That means minus I will not create any hindrance to the analyticity of fz. So I may take this as my fz, right? This as my fz. This is my fz. So I can write it, this integral is equal to integral c fz by z minus I. Now you see this I here. This I is my z0, right? fz by z minus z0. So what is my fz now? My fz is ln z plus 1 by z minus I, which is not analytic at, right? Which is not analytic at, which is not analytic at this ln 0 does not exist at -1, and denominator is equal to 0 at I, and -1 is outside, I is outside, which are outside your path C. This is my path C, right? This is my path. So outside the path C, outside the path C. So this implies fz is analytic everywhere in your C. Now analytic, actually what is my annular region here? The annular region here is, right, now you see this annular region here is this is my annular region here, multiple connected domain. This is my annular region here, right? So here it is, orientation is clockwise, anti-clockwise, and here this orientation is clockwise, right? And this orientation is clockwise, and you return back, and you return back here, and it is this anti-clockwise is maintained, okay? And I is here in this, okay? Here I is in the annular region D. So now fz is analytic everywhere in your D. This domain is my D, in D, in the annular region, right? So what is your Cauchy integral formula? Thus by Cauchy integral formula. What about your I? Now by Cauchy integral formula, it is for your multiply connected domain, okay? It is for your multiply connected domain, right? It will be your f of z0 is equal to 1 by 2 pi I integral over c1 fz by z minus z0 dz minus fz by z minus z0 integral over c2 dz, okay? So what happens to your z0 now? Your z0 is equal to I. You see z0 is equal to your I here, z0 is equal to I here for both this curve. So these two are not different integral, these are one combined integral. Okay, now this is my C1 path, and this inner here is your C2 path. This is your C2 path. So for C1 path, right, for C1 path, this is treated as, so now you see for C2 path, I is also outside. For C2 path, I is outside and this is outside. So this total is my fz here. So I can write it 2 pi I into f of z0. So this is equal to your integral over C1 fz by z minus z0 dz, and this is my completely, you say it here, fz dz, this total path. Now this fz is, this is over C2, it is analytic everywhere. Fz is your analytic everywhere. So by Cauchy integral theorem, this is 0. So this integral is 0, right? So this is 0 by Cauchy integral formula, right? So only this integral will be this much now. So therefore my integral C, right, integral C1 fz by z minus z0 dz minus integral over C2, it is at 0. So this is equal to 2 pi I into f of z0. So this is equal to 2 pi I f of z0. It is in view of this. What is your f of z0? It is f of I. So this is equal to 2 pi I into your log, the function is fz, what we have taken here, it is log z plus 1 by z plus I. So this is log I plus 1 divided by, in the denominator it is 2i, right? Your 2i cancelled, it is your pi log I plus 1. So therefore the given integral is, integral over C, right, integral over C ln z by, so therefore integral over C ln z by ln z plus 1 divided by z square plus 1 dz is pi log, this is capital L given, pi log I plus 1 plus I. So consider example 4. Evaluate this integral over this path. So first we have to understand the path, then we decide which one is z0 and which one is fz. So you have in complex plane, the path is the vertices of a rectangle, it is 2 plus I, it is in x-axis it is 2, y-axis it is 1, it is 2 plus I, it is 2 minus I, 2 plus I, 2 minus I, minus 2 plus I, minus 2 plus I, and it is minus 2 minus I. So this is the rectangle given to you. Right. So now what about, if you think this z square minus 1, then it is z minus 1 into z plus 1, right? So here minus and plus 1, minus 1 and plus 1, this is your minus 1, this is your plus 1, okay? So we have to write this integral I, we have to write it, right? This I is equal to integral C cos pi z into 1 by z minus 1 into z plus 1. Now we apply the partial fraction here. So this is equal to integral C cos pi z, here a by z minus 1 and b by z plus 1. It becomes here half, a and b are half, it will come half here. So this is 1 by z minus 1 minus 1 by z plus 1, right? So we take fz is this. So this is equal to 1 by 2 integral C cos pi z by z minus 1 minus 1 by 2 integral C cos pi z by z plus 1. So here this is your fz. So this is your fz here, right? And z0 is here. Z0 is this 1 is z0 here, and minus 1 is z0 here. So fz is equal to cos pi z. Fz is equal to cos pi z is analytic everywhere, right? Everywhere in C. Clear? So by Cauchy integral formula, what we are getting? So this is equal to 1 by 2. 1 by 2 in both the cases, it is 2 pi I into f of 1 minus 2 pi I into f of minus 1, right? So this 2 and 2 cancelled here, 2 and 2 cancelled here. So f of 1, this is equal to pi I into f of 1 is cos pi minus pi I into cos of minus theta is cos theta. Here cos of pi, because cos of minus theta is cos theta, right? Since cos of minus theta is cos theta. So what we are getting? So this and this cancelled. So this integral becomes here 0, right? It is at 0. Let us solve few more examples. So coming to example 5, we have to first evaluate this integral. This integral, let it be my I, and this integral is my I over this path. First we have to draw the path, right? It is the circle with center at 2. Center at, this is 1, this is 2. Center at 2, and the radius is half. The radius is half here, right? So it will come to 2.5, right? It will come to here 1.5 here, right? So now what about this? So here I is equal to integral c z by z square minus 3z plus 2. So this is equal to integral c z by, if you factorize middle term factorization, it is z minus 2 into z minus 1. So you see here, so now you see here 1 is here now, but 2 is inside. So now 1 being outside this, so it will not hamper the analyticity if I take it within your fz, okay? If I take it within fz, if I take this is my fz, right? So this is equal to my integral c fz by z minus z0. So with my z0 is equal to 2, z0 is inside c, it is inside c, right? But fz is equal to, and fz is equal to, what is your fz? Here fz is equal to, fz is equal to, fz is your z by z minus 1, is analytic everywhere except at z is equal to 1 here outside c, which is outside c. So that means fz is analytic everywhere in c, and z0 lies in c. So thus by Cauchy integral formula, this integral I is 2 pi I into f of z0, right? Suppose this is asked that, suppose it is asked that evaluate it in clockwise sense. It is asked that in clockwise sense. Since it is in clockwise sense, we have minus 2 pi I. It is because of clockwise orientation. So this is equal to minus 2 pi I. Here fz is this. So what is your f of 2? So it will be here 2 by 2 minus 1 is 2 here, right? So f of z0 is my 2 here. So this is equal to my 2. So minus 4 pi I. It is in clockwise. And if it is asked anti-clockwise, then here anti-clockwise means positive orientation, then it will be a 4 pi I. So this is your answer, right? evaluate it clockwise and anti-clockwise. Okay. Now coming to the last example, evaluate this integral and the path is this. First we have to draw the path here, plot the path here. We have in complex plane, center at 2, radius 2. So center 2 here, radius 2, so it will come up to here 0, right? Center 2 and this will come up to here 4. Now look at the denominator here. So the denominator indicates here z square plus 1 is equal to 0 is your minus I and plus I. Your minus I is here and your plus I is here, and here, and this indicates 3 and minus 3. So 3 is here, and your minus 3 is here. So you see this point is outside, this point is outside, this point is outside. So I will take z0 is equal to 3 only. So this is my z0 is equal to 3. So otherwise, so if I take this integral as this is my I, so solution, let my I is equal to integral C. If I take it z by z square plus 1 into z plus 3, right, divided by z minus 3, then there will be no harm, right? So this integral is of the form integral C fz dz by z minus z0. So with my z0 is equal to 3 because it is lies in C, and fz is my z by z square plus 1 into z plus 3 is analytic everywhere in C, right? It is not analytic at these 3 points, but it is outside. So what is my f of 3 now? So this is my 3 by, it is a 10 into 6, right? 6, it is a 2, so it is 1 by 20. Therefore, by Cauchy integral formula, here I is equal to 2 pi I into f of 3. So this is 2 pi I into 1 by 20 is pi I by 10. So this is your answer. So let us close this lecture here. So in this lecture we have discussed the Cauchy integral theorem, Cauchy integral formula. In the previous lecture we have discussed Cauchy integral theorem. Now in this lecture what we see? Now for z0 in C, right, this path C, closed path, we find f of z0 is equal to 1 by 2 pi I integral fz by z minus z0 dz. Now the question is, if it is asked that f nth derivative at z0, then how to deal with this? So to deal with, we have to learn your Cauchy integral formula extension. Cauchy integral formula extension here, and it will deal with the nth derivative of f at z0 point, z0 in C, right? And this can be addressed by Cauchy integral formula extension. So this will be my upcoming lecture. Okay. So to make this study complete, we have to learn this also. So subsequently, immediately in the next lecture, I will discuss that. Okay. So now if you feel this lecture is useful and interesting, please like and subscribe to this channel, which will boost my motivation to upload subsequent lectures for your benefits. Okay. So thank you all. So let us close this lecture here.